So this is something we've done before. 100% we did this, algebra 2. This is totally normal stuff. This is a quadratic because we have our power of 2, so a square. So we know our parent table. The parent function, whenever we have something squared, that's just our x squared. The parent function is always the simplest version that has that same amount of exponent, that same power. Bless you. And on that page I gave you guys the parent tables because we should hopefully know them. Where we have our good view of the middle, so we have 0 in the middle, couple numbers bigger, couple numbers smaller. And if we put it through that x squared, negative 2 squared is 4, negative 1 squared is 1, 0, 1, and 4. So we know what a parabola is going to look like. Like that's a guy we've dealt with before. It's a U. When we're doing these transformations, and the way we typically do them is making our transformation table, where what we've done before is we've taken our x plus h, and we always remember how much graphing makes us yak, y times a plus k, these guys, right? What pieces do we have here in this equation? A, h, or k? A and h. What is our a? 2. So we're going to take our y's times 2. We don't have any k, so we're adding 0 essentially. What is our h? Positive 3. So we're going to take our x values and add 3. This is what we've done before. All these other pieces. So we're taking our x values from our parent function and adding 3. So my negative 2 plus 3 is going to give us a 1. Negative 1 plus 3 is going to give us a 2. And then we'll have 3. And then we'll have 4. And then we'll have 5, because 2 plus 3 gives us 5. So it's using those x values that we have. Taking our y values times our a. 4 times 2 gives me 8. 1 times 2 gives me 2. 0 times 2 is 0. 2 and 8. So if we were to plot these points up, which we're gonna, we have our 1, 8. Whoa. 1, 8. 2, 2. 3, 0, 4, 2, and 5, 8. This is our transformed function. If you want to put your parent function on here so you can see what happened, you absolutely can, totally valid. If not, I get that too. For some of us, it's really helpful. For some of us, it's not. Because what we expect to happen with our transformed function here, with that a value of 2, we expect there to be a stretch of some sort, that vertical stretch. And with our h of positive 3, that horizontal shift should have gone to the right. And if we look at the parent function, which I sketched up here in light gray, definitely this has been stretched taller and it's been shifted to the right, which is exactly what we expected to happen. So we can use the A, H, and K stuff to help us figure out what's going to go on. The piece that's different for us, that new piece that we had in our equations, is that B. B, which works very, very similarly to A, but everything was flipped and backwards, right? So what we're going to do when we're looking at our transformations here, these stay exactly the same. We're still going to have our y plus k, are still x plus h. It's just when we're working in B, since it's very much like A, but it's been flipped, those numbers were all backwards, we have 1 over B times x. We need the reciprocal of b. So when we're working with these transformations, it's 1 over b times x plus h and ya plus k. Because if we think about that horizontal stretch was when our b was smaller than 1 instead of the stretch being when it was bigger than 1. That's what I mean by everything being flipped. And we're going to work with this a bunch today. We're going to work with quadratics. We're going to do this with square roots. We're going to do this with cubes. We're going to do it with absolute values. Depending on how much time, we're going to do as many as we can. That's what today and tomorrow are, kind of piecing these pieces together. So let's take a look at something that has a b transformation in it. Questions on this one before I look at the next one? Okay. So here's our next function. We've got this 1/4 x being squared. So there's the number times x inside the parentheses. That's what our b is going to be. And this plus 3 on the end, what letter is this one? A, H, or K? K. Because again, H would still be added inside the expression. So this guy is a B. This guy is a K. So we expect this thing to be scooched up 3. And since our B is very small, our B is little, we expect this to have a horizontal stretch. So it should look like somebody's taken our parabola and stretched it sideways. It happens. So this is going to use our x squared parent function. So it's still using the x squared parent function where we had our x's with our y's. -2, -1, 0, 1, and 2. 4, 1, 0, 1, 4. So it's still that same parent function. And again, if you want to sketch your parent function in, you totally can. I'm not going to ask you to, but for some of us, it's really helpful to see what's going on. Somewhere up there like that. So that's our parent function, but that's not what we care about. We want to make our transformed function. So we're going to take some very similar pieces, our ya plus k, and then we have our x plus h, which is the old way. And we also need to include, since we have that b, 1 over b. So it's the reciprocal of b. We need to flip b. So in this particular case, we have that b of 1/4. What is the reciprocal of 1/4? 4. It's 1 over 1/4, or the same thing as 4. So what we're going to be doing with our x's in here is we're going to take our x's times 4. We don't have an a value, so we're not going to times by anything, but we are going to add that k on there, plus 3. So if we had an h, we'd add that over here. If we had an a, we'd times that over here. But the thing with b is we times our x by 1 over b. And we'll see how that gives us our stretch horizontally. So what we're going to do is we're going to take our x's from our parent function and times them by 4. So my -2 is going to become -8.
You always take the reciprocal.
Always the reciprocal of b. Every single time. Our -1 is going to become a -4. Our 0 times 4 is 0. I can hear somebody's drum beat up here. 1 times 4 is 4. And 2 times 4 is 8. So we're still using the same concept before as our transformation table. We just are working in this 1 over b. Our y times a plus k, all we had was that 3, so we're going to just add our 3. 4 plus 3 gives us 7. 1 plus 3 gives us 4. 0 plus 3 is 3. 1 plus 3 is 4. And 4 plus 3 is 7. So that gives us our points to plot up. And things are going to be spread out really, really far. And that's okay. So our -8, +7 is way up here. -4, +4. 0, 3. 4, 4. And 8, 7. There we go. And this is where we can really see what we mean by a horizontal stretch. These points got yoinked, stretched way far out. Still got that up 3, but it's been horizontally stretched. It's been made wider. It looks very similar to when we have a vertical compression, but instead of smushing our points this way, it stretches them that way. Yes, dear.
Can you do scissors?
Oh, yeah. I was like, I have more. I just have limited, number of things that fit in the boxes, and then sometimes also stuff wanders away. So, yeah, we need different scissors or glue. I have tons of spares. Let me know. I'm happy to switch them out. So quadratics we've done bunches and bunches of times. We've worked with quadratics in Algebra 2 bunches. So we know how to find our parent table. We know how to apply transformations. Questions on this one? Because the weird part is the 1 over b. Okay. For all the functions, it's going to be exactly the same. The same kind of transformation. The thing that's going to change is our parent table and finding our a, b, h, and k. So we're going to practice this with several different kinds of functions today. So quadratics are something we're very, very familiar with. We've worked with them a gabillion times. So I'm not going to do tons of practice with quadratics. Questions on this one? Just checking in again. So let's remember how to do an absolute value, and then we'll start tossing some weird transformations in our absolute values. So absolute values, again, they're on that page that I gave you with our parent tables. So this is really good for kind of that initial remembering, but we don't want to rely on it too heavy because this is not, not giving you this page on the test. But absolute values are parent function. That's when we have just the absolute value of x. So for our parent, when we pick our x's to find our y's, and we use our -2, -1, 0, 1, and 2. When in doubt, those are good options to pick because they give us a really good view of the center. So even if we forget the parent table for an absolute value, well, I know the absolute value of -2 is +2. The absolute value of -1 is +1. The absolute value of 0 is 0. And 1 and 2. So absolute values, those are our very, very V-shaped graphs, where they look like this. Again, you don't have to graph the parent function. If it helps you, graph it. If it doesn't help you, don't graph it. Oof, that is a really terrible line. Oh my gosh. Okay. Less terrible. So that would be what the parent function for our absolute values look like. With this first one we're given here, what pieces do we have? A, B, H, or K? H and K. What is our H? 5. What is our K? -4. So what do we expect to happen? Right 5? Down 4. So when we're filling in our transformation table, we always have our graphing makes us yak, ya plus k. And you can either have our just x plus h and only think about the b when it's there. You can put it as our 1 over b, x plus h. Some places will write it as x over b. Same thing as if I have x times 1 over b. Whatever works for your brain, however you want to write it down, I don't care. I'm going to show you several ways to do it. In this case, it genuinely doesn't matter because I don't have a b value. I don't have an a value. We just have h and k. So our adding h, adding 5 means we're going to wind up with -2 plus 5, giving us 3, 4, 5, 6, and 7. And taking away 4, we're going to have -2, -3, -4, -3, and -2. So plotting up these points, we should get a graph that looks like this. Absolute values are going to be one of the few where we actually do want to use a straight edge of some sort. Calculator, edge of phone, edge of piece of paper, ruler, post-it note, index card, something, anything. Absolute values are based off of straight lines. But other than that and linear equations, everything else is going to be kind of curved. So we've worked absolute values before. In Algebra 2, we did those. Question on those before we put our weird transformations in. Yep, no worries. Just checking in for questions. And you can do these tables in any number of ways. I know some people that'll do them with the parent function in the middle, with transformations to the outside, or some people do it with parent function on the outside, transformations to the middle. I've seen them done like this, as two separate tables, as one big, like, kind of H-looking table. There's lots of different ways to write things. Again, whatever works for your brain, I can work around, as long as you show me some work. Don't just magically create an image without something on the paper. Give me a table, at least. Okay. Ready for the next one? So now we're going to work with one of those B's. So we have another absolute value here. So we're going to have that same parent function, that same parent table for the other absolute value. When we had -2, -1, 0, 1, and 2 with the y values of 2, 1, 0, 1, and 2. So the parent table doesn't change. Once we have our function, that's going to be the same parent table every time. When it comes to our transformations here, what pieces do we have? We have a b in here. So our
How do you tell if it's a B?
b is inside the function. So see how this is inside the absolute value? Inside the absolute value bars? That means this is B. If it was out front, then it would be an A. A is multiplied out in front. So if it helps, you can always think this would be A, absolute value B, X minus H, plus K. All right. And I know it's very, very small and kind of on the edge. That's what the transformation form on absolute values looks like. So A would be multiplied out in front, B is multiplied inside. It's still X minus H, K would be added on the end. So we've got our B here. What else we got? H. What value does our H have? Our H is -3. Our B is that 1/2. So when we're doing our transformations here, what we're going to do is we're going to take either our X over B or X times 1 over B plus our H and we would have our Y times A over K. Sorry, Y times A plus K. Brain broke for a second there. So in this particular case, what is 1 over B? 2. So this is going to be 2 times our X plus our H plus -3 or -3. I don't have a change for my A here. I don't have a change in my K here. So my Y's are going to stay exactly where they are. Technically, my A value is 1. Y times 1 plus 0. Nothing's changing. The only thing that's changing is my X values. So I'm going to take my X values over here, times 2, and then -3. So -2 times 2 gives us -4, -3, -7. -1 times 2 is going to give us a -2, -3 gives us a -5. 0 times 2 is 0, -3 is -3. 1 times 2 is 2, -3 is -1. And 2 times 2 is 4, -3 is +1. So we've got our new X values here. Our Y times 1 plus 0 means these are going to be exactly the same with our 2, 1, 0, 1, and 2. So plot up those points so that we can get this graphed up. So we're going to have our -7, +2. We have our -5, +1. Negative, I'm on the wrong spot there. There we go. -5, +1. -3, 0. -1, 1. And 1, 2. And our absolute values should look like this. And we can really see that horizontal stretch here, how it's been taken and stretched sideways. Our B was small, which means it's going to stretch sideways. Questions on this one? So I know these are weird and kind of awkward. Calculation-wise, they're not brutal, but they're just awkward and different. Okay. We're gonna do one more absolute value. We've got minus absolute value of 2x. So again, we base everything off of our parent table. I see an absolute value, so my very first step is going to be to write down my parent table. I know I'm going to need it. So the second I see absolute value bars, I write down my absolute value parent table. That -2, -1, 0, 1, and 2, with our 2, 1, 0, 1, 2. What pieces do we have here? A and B. What is our A? -1. What is our B? 2. So when we do our transformations over here, we don't have any H, we don't have any K, so those guys aren't changing. Say that again?
Does the y's are negative equals y?
Yep, because that A being negative, that's going to give us our reflection over the x-axis. So we're going to want to flip it upside down. So we know we're going to take our y's times that -1. That's our y times A plus K. But there's no K, so it's not adding anything. What are we going to wind up multiplying our x's by? 1/2, 1/2, the reciprocal of B. So our y's are going to times 1/2. Sorry, our x's are going to times 1/2. I'm good at words. X times 1/B plus h if we had one, but we don't have an h here, so that's just going to be what it's going to be. So we're going to wind up with some very small x's here. And that's okay. Because our x's are going to be -2 times 1/2 is going to give us a -1. -1 times 1/2, that gives us our -1/2. 0 times 1/2 is still 0. 1 times 1/2 is a 1/2. And 2 times 1/2 is 1. So our x's are getting squished this way. They're being compressed in. So this is our horizontal compression. So our y's are being times at -1, so we're going to get that reflection across the x-axis because we're going to have our y values at -2, -1, 0, -1, and -2. And so we're going to plot up these points. I'm going to sketch that parent function in so that we can see that and compare. You don't have to. I'm just giving it to us for now so that we can look at it and see what's happening here. Because when we plot up these points, our -1, -2, -1/2, -1, 0, 0, 1/2 -1, and 1 -2. And we connect these up with our lines. And we can see how that with that B of 2, we got that horizontal compression where it squeezed these together. These are the points of my parent function, and they got squished in. They got closer together. So when our B is littler, our points get farther apart, and when B is bigger, it gets squished in. Questions on this one? single page. Love it. Questions on this? Let's take a look at some cubes. We haven't worked with cubes in a hot minute, so let's practice one without the weird. Awesome. So here's a perfectly normal, absolutely average cube. Not anything different on this one than we've worked with before. So remembering for x cubed as our parent function, we typically use those same x values that could be the middle where we have our -2, -1, 0, 1, and 2. And if we cube them, we'll wind up with our -8, -1, 0, 1, and 8. So if we were to sketch our parent function up here, again, you don't have to. If it helps you, great. If it doesn't help you, don't do it. It makes this kind of skinny looking S-curve. Looks like Spring Mill Road. And go, what? So for our cubes, again, the process is 100% exactly the same. We'll have our 1 over b times x plus h, and our y times a plus k. And you can either think of it as 1 over b, or you can have it as x over b. It's always an adding h. The time when h has the different sign is when it's in here. If I take h out, it's going to have the opposite sign of this piece. So what is our h value? +4. So we're going to add 4 because it's going to switch to the right. Yeah. That's a really common mistake, actually, to accidentally switch where that is. Everything. Everybody. H always has the opposite sign, but only in the equation in here. If it's going out of or coming into the equation, like if I was writing a form, that's when it has that opposite sign. Every time else, it stays normal. So for this one, we have our h of 4, which we already saw. And on this one, we also have our k of 2. So this is totally a thing we can do. There's not even a new weird b on here. We're just going to take our x's plus our h. So we don't have a b. If we had a b, it would be multiplied in here inside with the x. A would be multiplied out front over here. So it's about whether it's inside or outside the parentheses. So we're just going to take our x's plus our h plus our 4. And we're going to take our y's plus our k plus that 2. So our -2 plus 4 gives us a +2. -1 plus 4 is a +3. 4, 5, and 6. For our y's, same vibe. +2, we're going to have -6, +1, +2, +3, and 11. Right? Oh, no, I was adding 3. Randomly. What? I'm good at mathing. I was looking at my page going, that's not the number I have there. What did I do wrong? My brain autopiloted weird. -1 plus 2, +1. 0 plus 2, 2. 1 plus 2, 3. 8 plus 2, 10. There we go. I randomly decided to add 3 because I could. It happens. Sometimes we just wind up autopiloting and changing things accidentally. So when we plot these up, R2, -6, 3, 1, 4, 2, 5, 3, and 6, 10. Way up here. Yes, sir. With the new transformation, that's like our new piece today. Because we had that B transformation in the list with the horizontal stretch and the horizontal compress. All the other pieces stay the same. It's just we have to take the reciprocal of B. Because it takes all those Y values and it does them in reverse is kind of the way to think of it. It flips A on its head. So it's got to be a reciprocal. So this is our first cubic transformation. Looks like this. We'll do one more cubic. Actually, we'll do one more graph. That'll be the last one we do.
Yeah.
Oh, there's that page. Okay, cool. Make sure you're picking the one I want. Yes, I want this one. Okay, questions on the cubics? Because I know it's been a hot minute since we worked with them. Because now we're going to do weird with it.
Ooh.
We've got another cubic here. We have a lot of pieces. I got my 1/2 parentheses minus x parentheses cubed plus 1. So first thing I notice is it's got that power of 3. I've got my cube, so I'm going to pull out my cubic parent table. So our x's with our y's. For the most part, almost all of the functions have the same x values in here. The only one that doesn't is our square roots because it has perfect squares because that makes our lives so much easier. Our cubes, we had our -8, our -1, 0, 1, and 8. So that's our parent function. You don't have to draw that in here if you don't want to. Totally valid.
Isn't it just the one?
So what do we have here? What pieces do we have? Yes, we have an A, we have a B, we have an H. So this guy out here,
An H.
no, not an H. We have a K.
It's a day.
It's a day. It's a day. We're gonna go with it. So we have our A of 1/2. I'd have got there when I got over to it. In here, this guy's our B. What's our value for our B? -1. And then what's this one over here? K. Our K is +1. So we expect this to A of 1/2. We're going to vertically compress. It's going to squish. Our B of -1, that's when we do our Beyonce flip. All the single ladies. This is B for Beyonce. So it goes this way. So it's going to go around our y-axis, so it's going to reflect this way. And then our K of 1 is going to shift up 1. So when we set up this table, we're going to have our x plus h, but we times by 1 over b. That's a b. So 1 over -1 is just -1 times our x. That's how we get that reflection across the y-axis, because that's going to take all these negative values and flip them to the other side. For our y's, taking our y times our a, just like normal, times our 1/2 plus k plus 1. So this is going to take all of our x's and flip them to the other side. So -2 times -1, we get our +2, +1, 0, -1, and -2. Our y's, we're going to shrink. So our y times 1/2, -8 times 1/2, we get -4, +1, -3. -1 times 1/2, You get negative 1/2 plus 1 is positive 1/2. 0 plus 1 is going to give us a 1. 1/2 times 1 is 1/2 plus 1 is 1.5 or 1.5 or 3/2. Whatever works better for you. I tend to go with mixed numbers or decimals when it comes to graphing. If you want to put an improper fraction, you do you. I just find 3/2 harder to graph than 1.5. 8 times 1/2 gives us 4, plus 1 gives us 5. And we've got points that we can plot. We've got our 2, negative 3. It's going to feel like we go backwards when we graph because now I have 1, 1/2, and now I'm going to the left. We've got 0, 1. I've got negative 1, 1.5, and negative 2, positive 5. That's what happens when our b is negative. Is it going to wind up feeling like we're working backwards across the graph? But it did a reflection across our y-axis here. Okay? So we treat them very much the same how we did A, H, and K. Okay? Tomorrow we're going to work with more of these. We're going to work with square roots, and then we're going to start smushing some together. I'm going to put up the homework numbers so we can see them. As of right now, those dates are still accurate. I make no promises to the future.
What day is the 25th?
Thursday.
Crap.
It happens. I'm going to talk with the other teacher. We'll see. Have a great rest of your day.